So let's continue. Same worksheet. Okay. And last time I write on the steps, right? This is the steps. When you see a rational function and you want to find the vertical asymptotes, you first factor, right? Factor completely. Do not multiply out. We want to factor. Okay? Everybody say factor. 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 Yes. Factor the numerator and denominator. And then your domain is you set the denominator not equal to 0. And then you set each of the factors not equal to 0. Right, everybody? And then the next step, for each of the number you find in step 2, you let x goes to that number from the right. Okay? So in this case, we have those two numbers. We let x goes to this number from the right. Then the corresponding factor will go to 0 plus. Is that okay, everybody? Yeah. Do you remember last time I told you we let it to go to this number from the right instead of from the left? Because 0 plus, no matter it's square or the power 1, it's still 0 plus. But if it's 0 minus square will become 0 plus. Okay, everybody? So that's why using 0 plus is better. It's less chance to make mistakes. Okay. And then for the other factors, you just plug in a number. And you don't need to use your calculator. You don't need to know what exactly the number is. You just need to know each factor. Is it positive or negative? Right, everybody? So we got it's negative, multiplied by negative, divided by negative. Oh, there are 3. Oh, this is cube. Cube, still negative, right? So 3 negatives together is still negative. So if you have an odd number of negatives multiplied together, you still get negative. If you have an even number of negatives multiplied together, you get positive. Right, everybody? Yeah. Yes. So once you get constant over 0 plus or 0 minus, you get infinity or minus infinity. Okay, that's good because that means we have a vertical asymptote. X equals to that number. Okay, everybody? And we do the same thing here. X goes to A from the right. Then the corresponding factor is x minus 8. And x minus 8 go to 0 plus. Right, everybody? And we plug in 8 into the other factors to realize all of them are positive. So that's why we get positive infinity. Okay? All right. So that's why we have 2 vertical asymptotes. Both of them are vertical asymptotes. Okay? And let's continue. Did I ask you to factor this problem last time? Yes? Okay. I see it. Okay, so let's factor it. So that equals step 1 factor. How can you factor the numerator? Thank you. Yeah, see everybody? We factor 4x squared, that gives us 4x and x. And we factor 3 is 1, 3, or minus 1, minus 3. Right, everybody? And we multiply the outside, we get minus 12x. We multiply the inside, we get minus x. So when we add them together, we get minus 13x. Right? That's perfect. This is the correct factorization. How about the denominator? Thank you. Right, everybody? We multiply the outside. We get 2x times negative 3 is negative 6x. Multiply the inside, we get x. So when we add them, we get minus 5x. Okay? this is the correct factoring. Do you see we have a common factor x minus 3? Yeah, we can cancel them, simplify them. Okay, everybody? So, but when you talk about the domain, you still need to include this factor in the domain. Okay? But you kind of imagine this because it's removable. So this guy will have a vertical asymptote there. But then this part, you expect to have a hole there. You don't have a vertical asymptote, a hole there. But in order to show all your work, you cannot just say, oh, I can see that the vertical asymptote is when this is 0, so it's just 1. That's the answer. That's the final answer. But to show all your work, imagine if this problem has 10 points, and then you tell me, oh, that's a vertical asymptote. You only get 1 or 2 points out of 10 points. Is that clear, everybody? You have to show all your work. Every step has points. Okay, everybody? So that's why I hope you can take notes in class. You can understand what's the requirement for each kind of problems. Okay, I would say factoring is 3 or 4 points of the problem. Okay, and then find the domain. Find the domain. You let the denominator not equal to 0. Right? You set the first factor not equal to 0, and the second factor not equal to 0. We solve for x. So x not equal to what number, Blake? Yeah, negative 1/2. And this x not equal to what number? Yeah, very good. Okay, so that's step 2. Right, step 3. You have to let x go to those numbers from the right. Yes, everybody? Because you say, oh, we have a vertical asymptote at x equals minus 1/2, but we don't have a vertical asymptote at x equals to 3. But why? You have to tell me why. How can you prove it using the limits? By definition of vertical asymptote, we have a vertical asymptote if the one-sided limit goes to infinity or minus infinity, right? And you don't have a vertical asymptote if your both sides, you don't go to infinity or minus infinity. Okay? So that is how to show it, how to prove it. Okay, so keep going. Limit x goes to the first number minus 1/2 from the right, f of x. Okay, and here you always plug in the factor form. Okay, you always plug in the factor form. Okay, so you plug in the factor form, and you can plug in the simplified factor form. Do not plug in the original form. If you plug in the original form, this is so ugly. Okay, and you can't even tell if the denominator will go to 0, but you cannot really tell it goes to 0 plus or 0 minus. It won't tell you. If you plug in the calculator, it just shows you 0 in the denominator. Okay, everybody? So plug in the factor form. And plug in the simplified factor form. If you can cancel some factors, right? Cancel it. So what do we have here? Yeah, exactly. So we have 4x minus 1 over 2x plus 1. Okay, everybody? All right. Let's see. So do you see the denominator when x goes to minus 1/2 from the right? This factor, the corresponding factor, 2x plus 1, goes to what? Yes, 0 plus.
Very good. And other factors we plug in. So 4 times minus 1/2 minus 1.
Yes. When you're plugging in, no matter what the number is, if it's going to on the positive side, the zero also be yes. Right. As long as you go to that number from the right, the leading factor, if the leading coefficient is positive, then it always goes to zero. Yes. Because it's like inequality. So you have x approaching it from the right. It's like inequality. If both sides multiply by 2 and you add 1, it serves the inequality. Okay? So as long as your leading coefficient is positive, you go to 0 first. Okay? But if your leading coefficient is negative, it's like you multiply both sides of the inequality. It puts the inequality. That's why you go to 0 minus. Right? It's actually the inequality. Okay, yeah, that's very good. So, oh, what happened here? Negative, so you get your numerator is negative, right? Do we need to know exactly what that number is? No, just negative number over 0 plus. The answer is,
what's the answer? Yes, negative infinity. Very good. All right, so that's 1 point. The other point, okay, goes to 3 on the right. Also plug in the simplified factor form. So far, so good, everybody? Oh, when we plug in, then we don't need to do the limit because we replace x by that number, right? So when we plug in 3, what's the numerator, Dylan? Yeah, oh, yeah, tell me that number. Yeah. Can you also tell me the denominator? Yes.
do you see everybody? We get a number. Yes, we get a number. It means the right side limit does not go to infinity or minus infinity, right? In this case, you also need to check the left side. And actually, you see here, when x goes to 3 from the left, you still do the same thing, you still plug in 3. You get the same number, okay? So, right now, you just go back and erase the plus. Is that okay, everybody? We do the plus first, and we get a number. Oh, we get a number. That means you have to check both sides and make sure both sides they don't go to infinity or minus infinity. Then you can confirm that there is no vertical asymptote. Okay, everybody? So we go back and erase the
Plus, okay? So let me write it down on your notes. Write down on your notes. So if you get a number, that means you need to check the two-sided limits. Okay? So go back and erase the plus sign. Okay? And because if you show the two-sided limits equals a number, then you can say there is no vertical asymptote. Is that okay, everybody? So just make this go away.
because I want you to know we're erasing it. Okay? So in the exam, we just erase the plus sign. Is that okay, everybody? I just put it down here so you know we go back and erase.
All right. Therefore, the vertical asymptote is X equals first number, -1/2. And we only have one vertical asymptote. This number, f3, is like a hole. You see the limit goes to 11/7. It's just like a hole, an open circle there. The point is missing. It's the left side limit and right side limit agrees. Is that okay, everybody? This is the complete proof of this problem. Okay? If this problem has 10 points, let me think about it. So maybe factoring is like 2 points, and then get these two numbers, another 2 points. So this step is 4 points. And this is maybe 3 points on this step, and then 3 points on this step, so you can write down the conclusions. Right? Yeah. So the together is 10 points. Okay, everybody clear about this? Right. Yeah. A typical mistake is students just cancel the 3 and only consider one number, and we just show the limit when x goes to 3 and what happens. In this case, even though the final answer is correct, but because we think that consideration of this number, you lose 3 points. Is that okay, everybody? Even though you cancel up here, you have to confirm. You have to show me why there's no vertical asymptote there. By showing the limit is a number, then you can confirm there's no vertical asymptote there. Okay, very good. That's example 3. Example 4. Find out the vertical asymptote of this. The first step we factor, right? H. Can you find a common factor of the numerator? What's the common factor? -x. Can you see that? -x. Alright. So tell me if we factor out -x, what's left? Yeah, x squared plus 5x minus 6. Very good. How about the denominator? How about Will? Oh, yes, sorry. All right, flip the sign. We flip the sign, yes. Right, everybody? After we factor out the -1, yes, we put the sign for all the terms. So this becomes plus, minus, plus. Yes, very good. And Will, what's the common factor of the denominator? Yes. So after you factor minus x squared, what's left? Minus? Yeah, very good. Right, everybody? Okay. Now, let's continue. Look at the numerator. Can we factor the numerator more? Oh, by the way, do you see the minus cancel? We can also cancel one copy of x. So we get, how can we factor that? Denominator, we have x and x plus 4. Can you factor this? Yeah, very good. Because it's positive x, positive 6, both factors have the same sign. So x minus 3 and x minus 2. Good. Right, everybody? Okay, that's the first step we factor. Second step, the domain is we set the denominator not equal to 0. And you be careful. Do you see here, even though we cancel out the x, we still have x in the denominator. So when we look at the domain, we still need to consider x cannot be 0. Okay, everybody? Alright, so x cannot be 0 and x cannot be... Yeah, -4. Okay. Step 3. We have two numbers. For both numbers, we need to check the right side limits. Okay, down J. So, where do we plug in? Do we plug in the original equation? We plug in the factor form, right? The simplified factor form. So we have x minus 3, x minus 2, x, and x plus 4. Is that okay, everybody? Mm-hmm. Okay, Donjay, tell me, how do we change each factor? This becomes what? Oh, by the way, if x goes to 0, which factor goes to 0 plus? The first x. Replace x by 0 plus. Why? Because x corresponds to this factor. If next one x goes to -4 from the right, it corresponds to the factor x plus 4. Okay, so you look at that factor first. Replace the x by 0 plus. And then the other factors, you plug in x is 0. Okay, everybody? Mm-hmm. So 0 plus, and you plug in x is 0. What do you get? You just get -3, right? -2 and 4. What's your answer? Negative? Positive infinity. Oh, you remember? Yeah. Constant over 0 plus or 0 minus, you always get infinity or minus infinity. But you look at how many negative signs do you see in this quotient to figure out is positive infinity or minus infinity. All right, next, George, right? Next, your turn. So x goes to -4 from the right. You also plug in the factor form, right? So let's write it down. Plug in the factor form. Okay, what do? Plug in -4, right? Which factor you replace by? The x plus 4 replaced by 0 plus. Okay, you replace by 0 plus, and the other factor plug in x is -4. Can you tell me the first factor on the top, is it positive or negative? Negative, right? How about second factor? Negative. Oh, the bottom one, negative. So what is your answer? Negative infinity. Yeah. Right, everybody? Mm-hmm. So good. We actually get two vertical asymptotes. So there x is 0 and x equals -4. So far, so good, everybody? Mm-hmm. Yes, this is the true solution of this type of problem. All right. Any questions? All good? Okay. Oh, sure. Yes. Okay. So this is vertical asymptotes. And we have the x goes to a number, the y goes to infinity. The next topic is going to be limit at infinity. In this case, you let the x go to infinity. Okay? So, two directions. This side
x goes to minus infinity. And this side, x goes to infinity. So only two possibilities, only two directions. Right.
So that's why here, definition. If f of x becomes arbitrarily close to a finite number L for all sufficiently large positive x, we write the limit x goes to infinity, f of x equals to L.
And you can look at this picture. See, this is like a y equals L is a horizontal line, right? We are approaching it from the bottom, and here we're approaching it from the top. And here you can have some picture like this, right? Like you remember the sine, cosine, alpha, and if you multiply by something, it's getting close to 0, and this is the picture. It looks like this. Okay. All right.
And similarly, if f of x becomes arbitrarily close to a finite number L for all sufficiently large negative x, so x goes to minus infinity, then we write a limit x goes to minus infinity, f of x equals L. And the picture is like you approaching the horizontal line, when x goes to minus infinity. Okay? And in both cases, we say this horizontal line is a horizontal asymptote. Okay? The last class is about vertical asymptote. This class is about horizontal asymptote. That's why when you answer questions, don't just give me a number. Don't just say vertical asymptote are 0 and minus 4. Vertical asymptotes are lines. Line is an equation. The x equals to a number that gives you vertical line. The y equals a number gives you horizontal line. Is that clear, everybody? Mm-hmm. Okay, good. Let's keep going. Alright, so before we do examples, I want to make a comparison with you. Okay, so let's use some space here. Let's make a comparison. So here, vertical asymptote and horizontal asymptotes. Okay, let's talk about the number of vertical asymptotes. We can have 0 vertical asymptote, we can have 1 vertical asymptote, we can have 2 vertical asymptote, and we can have infinitely many vertical asymptotes. Do you remember the graph of tangent? Zoom, zoom, zoom. Remember that? Yes, you have infinitely many vertical asymptotes, right? But how about horizontal asymptote? Well, you can have one on the left when x goes to minus infinity. You might have another one when x goes to positive infinity. But there are at most two, because it can only go to two directions. Right, everybody? So the number of horizontal asymptotes, it could be no horizontal asymptote, or one horizontal asymptote, or two horizontal asymptotes, but at most two. Is that okay, everybody? Mm-hmm. Yeah, write it down on your notes. Okay, next property. Can you cross the vertical asymptote? No. In order to be a function, we approaching it, but we cannot cross it. Right, everybody? Mm-hmm. So we cannot cross the vertical asymptote. Horizontal asymptote. Can you cross it? Can you cross it? Yes. Right? So we can cross it. You can cross it as many times as you like. See, this graph you cross it infinitely many times. Mm-hmm. Okay, next one. So vertical asymptote. Oops, sorry. What am I doing? I don't want to change it. Okay. So vertical asymptotes, they are vertical lines. Okay, so they are vertical lines. So vertical lines, it means x equals to a number. So x equals to a number. Horizontal asymptote, they are horizontal lines. So you get y equals a number. Okay? And when we check the limits, for vertical asymptote, we're letting x goes to a from the right, and we see whether we get positive infinity or minus infinity. Yeah, if yes, then we get a vertical asymptote. But horizontal asymptote, we are letting the x goes to infinity or minus infinity, and you want to see if your y is approaching to a finite number. Do you see it's like you aim to change the position of it? Yeah. So that's the comparison. Okay. So write out the comparison to avoid confusion. All right. So how do we find horizontal asymptotes? Here, I also want to make a comparison with you about the steps, because in the exams, you will have a problem that you need to find both. Okay, so you need to find vertical asymptote and you need to find horizontal asymptote. Okay, everybody? So remember, what's the first step when you find vertical asymptotes? Factor. The second step, find the domain, right? And 3 for each number outside of the domain. So for each number outside of the domain, you check the limit, right? If you get infinity or minus infinity, then the vertical asymptote is x equals to a. Right, everybody? If you get a number, then you need to check the two-sided limits to show it equals to the number. It might be the same number, it might be the different numbers, that's possible. Okay, so but if you get both sides, get a number, then you have no vertical asymptotes. Is that okay, everybody? Okay, that's for vertical asymptote. And horizontal asymptote, what do you do? Okay, you look at the dominant term of the numerator. So you look at dominant term of numerator. Let me write it down. Dominant term of the numerator and the dominant term of the denominator. So from now on, to make things easy, we just call it DTN, dominant term of numerator, and DDT, dominant term of denominator. Is that okay, everybody? It's like does not exist, DND. Okay? So, you look at this. Because it's really end behavior. Your x goes to infinity. Your x goes to infinity, do you care about the smaller terms? It's like you have $1 million. Do you care about a penny? I mean, not that much if you only have 50 cents, right? So look at the dominant term of the numerator and denominator. Then you can compute the limit when x goes to infinity or minus infinity. If you get a number, then let's say the number is L. Okay, if you get the number is L, then you have a horizontal asymptote, y equals to that number L. Okay, everybody? But if you get infinity or minus infinity, then we don't have any horizontal asymptotes. Is that okay, everybody? Like the picture, look at the picture. Zoom, it goes up there. You're not approaching to any horizontal line. It goes to infinity. or minus infinity. So no horizontal asymptotes. Okay, everybody? In the exam, you need to do both. Okay, so make sure you memorize the set and do not confuse. Okay? All right. So here, let's do that. So we want to find horizontal asymptotes. Look at the dominant term of the numerator. What's the dominant term of the numerator? For term also include coefficients. Yes. 4x squared. Right, everybody? Mm-hmm. And what is the dominant term of the denominator? 2x squared. See here, do we need to factor? No. Don't factor it. Okay, when you find a horizontal asymptote, you just look at the dominant terms. You don't care about the smaller terms. Okay? And then you can compute the limit. So there are two limits you need to consider. X goes to infinity and x goes to minus infinity. And when x goes to infinity, you just need to put down the dominant terms. The dominant term of the numerator is 4x squared. The dominant term of the denominator is 2x squared. So far, so good, everybody? Do you see what happened? Do you see x squared cancel? What's left? 2. Oh, we get a number. It's 2, right? Nice. If we get a number 2, then we have a horizontal asymptote, y equals to 2. Okay?
So,
Yes.
when you were getting number and those horizontal asymptotes,
Say again.
so like when you were trying to find vertical asymptote
Mm-hmm.
and you get a number,
Then we don't have any vertical asymptote.
so you say
No, because vertical asymptote, you're letting x goes to a finite number. In order to get horizontal asymptote, you're letting x goes to infinity or minus infinity. Okay, you need to approaching it. You need to approaching it. Okay, at the end. So yes, that's a good point. That's why it's very easy to get confused. Where do I put the infinity? So draw the picture to help you to understand. Okay? And in this case, when x goes to minus infinity, do you realize it's the same thing? We also cancel the x squared and we also get 2. You realize for this problem, no matter you go to infinity or minus infinity, you approach to the same horizontal line. Right, everybody? So the horizontal asymptote is y equals to 2. Okay, so this is how you show it. Let me talk about this more. Okay, so here. And let me get to our website. So 3.1 notes with answers. Okay, so I want to talk about a formal proof of this. Okay, so a formal proof of this would be your numerator and denominator divided by the highest x power. Do you see the highest x power is x squared? You divide by x squared. Okay, then you distribute. When you distribute, do you see 4x squared over x squared become 4? And then minus 13x over x squared become 13 over x. And here 3 over x squared. And also you distribute the denominator. You get something like this.
And now you're using the fact that 1 over 0 is undefined, 1 over 0 plus is infinity, 1 over 0 minus is minus infinity, but 1 over infinity is 0. 1 over minus infinity is also 0. That's why here, when you let x go to infinity, this term goes to 0. 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 So you're only left with 4 over 2, which is 2. This is the formal proof. Okay? But to make things easier, I make this shortcut proof. So you can use this shortcut proof in the exam or homework. Okay? So you don't need to write about the lower terms. Just look at the dominant terms. Okay? But this is the formal proof. Okay? Yeah.
All right. Good. Let's keep going. Okay.
So look at this problem again. We look at the dominant term of the numerator.
And dominant term of the denominator. So in the exam,
You have to write out DTN. Okay, everybody? Because if you use the shortcut proof, I want you to list all the steps. So DTN, what's DTN? Theta. Yeah, 4x, right?
how about DTD?
Let's look at the power. Do you see this is square root? But do you see this is square? When you take the square root of the square, you get power 1. Do you agree? So this term is power 1. This term is like 1. This term is also like power 1. Do you see, everybody? So when you look at the dominant term of the denominator, there are actually 2 terms we need to consider. This one and this one. Okay, everybody? So, yes.
You just drop the plus one like that.
Huh?
Just not when you use the plus one.
Oh, dominant term, the highest power term.
But usually it's under the
Yes.
square root.
Exactly. Because we only look at the highest power term. Any lower power, forget about it. This is the shortcut proof. Okay? The shortcut proof, we can only look at the highest power term. But it's not highest power, forget about it. The formal proof view. The formal proof, when you move the x down there, that term will become 0 if it's lower power. Okay, that's why it won't make a difference.
Okay, so we got this term, but don't forget the square root 9x squared and also the 7x. What's square root of 9? 3, right? And you have square root of x squared. Okay, here you gotta be very, very careful because square roots of x squared is not just x. It's actually absolute value of x. Why? Think about it. I give you minus 2 squared. What's that? 4. And when you take square root, what's square root of 4? 2.
Do you see when your x is negative, when you take square root, you get positive, right? That's why this is actually
Absolute value of x. It's not just x. That's why you have to separate into cases. Okay? Case 1, if x is greater or equal to 0,
your absolute value of x is just x.
is that okay, everybody? Yeah, so it's x if x is greater or equal to 0. And when x is less than 0, any guess? What's absolute value of x when x is less than 0? It will be minus x.
Because x is negative, minus x will be positive, right, everybody?
So see, if x is greater or equal to 0, you get 3x plus 7x, which is 10x. But if x is less than 0, you get what? 3 times negative x plus 7x. What's that? 4x. Yeah. You know, this difference can give us two different horizontal asymptotes. Yes. Let's do that. When x goes to infinity, what's the dominant term of your numerator? Numerator. 4x. What's dominant term of your denominator? 10x. X goes to infinity. X is positive, right? X is positive. So we get 10x. Oh, what's that? 4 over 10, which is 2/5, right, everybody? And on the other hand, when x goes to minus infinity, what's your numerator? 4x. But what's your denominator? 4x. What do you get? 1. Oh, we get different numbers. So we have two different horizontal asymptotes. They are what? X or y equals? Y equals 2/5 and what? Y equals 1. Okay? Do look at example 1 and example 2. Example 1, just regular rational function. Do you see the two-sided? You go to the same horizontal asymptotes, right? The second problem, because of the square roots of x to the even power, they give an absolute value of x. And it goes to different horizontal asymptotes. Okay? So if you see square roots of x to the even power, be careful. You might have two different horizontal asymptotes. Okay? So let's continue next week. Have a nice weekend. Yeah, and keep working on your homework. Yeah.
Oh, Professor, can I have the sheet?
Did I not give you a attendance sheet today? Oh, yeah. Oh, over there.
Ready for next homework?
Next homework is due next week. Let's see. Next week. Oh, not here. Where is it? I think next Friday. Yes, next Friday you have homework 2 and quiz 1. The quiz 1 will cover homework 1 and homework 2 stuff. Okay? Save.